on a return period basis. Now, our objective was to identify the regions in Karnataka as such. We started with Kaveri. We had an experience of 3 regions, 3 unique regions forming with some sensible regression equations. So when we had the Krishna data from CWC, a lot of data was handed over from Central Water Commission. About 2,302 station years were furnished to us, and we did combine all Tungabhadra, Bhadra and the Ghataprabha, Malaprabha area with some Bhima, Upper Bhima also, Maharashtra area. And we started the regional fitting by using L moments. I'll just go through how we went about. See, the object was to fit for the regional frequency curve, and also individual stations we identified the best fit equations. This is very much used to our field engineers, and I am using it in my office also at this stage. Now the generated expressions can be extrapolated also. See, we have 30 years of data, and if you need 100 years as per our design flood requirements in the code, we can use it on extrapolated basis. And this is said to be the say trade-off of time over area, and that is the use of our regional studies. Now this is a brief description. All our seniors have spoken enough. The dam, 100 years, I am not talking of major and intermediate dams. This work pertains are relevant to only minor dams. There are a lot of minor dams in Karnataka also. Probably this approach can also give some insight into the return period floods on a, say, with some error and all that. Okay. See, diversion works, we can use cross drainage works. The IS code doesn't specify which method we have to use. We saw this whether you have to use your flood estimation report or our regional analysis, and who is to authorize this regional analysis. This is the first step. This is the first step of the regional equations we have found. Now, this is the study area. Already our senior Bhopal Singh has shown the area. And the Karnataka region only have chosen about 1,15,000 square kilometers with 88 gauge sites. This is the L moment equations. This Hosking has given a order statistic defining these values. And what is important about this is the T and T3, T4, these describe the distribution, the probability distribution that the sample set has. And for any distribution, probability distribution, the plot is unique. No two distributions are identical. They are quite unique. In that, if we have the sample set, if we plot our the moments LQness, SQness and the kurtosis, it plots on this graph. This is a test graph. This is a test graph given by Hosking, very useful for us field engineers. See, we need not know too much of probability statistics. Use this test graph, we know the probability that we have to apply. So in that 3 parameters, plot like a line, the 2 parameters are just like points, and this graph has been used for our analysis, or this methodology has been used. Now the data collection, I told you already. We have considered only annual maxima, as we have already more than 10 years of data is there for any station. 10 to 43 years of data is there, and total data set is 2,300. Now the catchment area is also very small to very big. So this adequately represents the geomorphological and the climatological changes within the catchment area. And you can observe the mean flood per unit catchment. It is very arid to some humid region also. Now, we do the data screening as prescribed in your Central Water Commission say guidelines. A lot of books are given, and we have used. This is the first step of the homogeneity test we adopted. That is, entire 88 data sets were put for this test graph, wherein the Q10 of the predicted Q10, we used the generalized extreme value distribution for the data set, and that Q10 by the Q mean of that particular site has been divided, and the average of that Q10 by Q mean is again multiplied with the Q mean of that gauge site, and for that the return period is worked out. And this plots like this, and it seems to be homogeneous. So our experience in Kaveri had shown 3 regions. So we got interested, let us divide it to 3 regions to improve the I think, homogeneity. So L moments, these are worked, identified the similar stations, the DI test as prescribed by Hosking, the heterogeneity index, and all those prescriptions given in the books were followed using Excel sheet. We used only MX Excel, we didn't have any sophisticated software or anything. These are the growth factors we got on the regional scale. The three regions are unique. They have different patterns of this growth functions. One is from 1.44 to 2.48, the other one 1.77 to 3.61. The regression equations are shown below. The mean annual flood as a function of area. The R squared values are written, it is 0.4 to 0.56. And some to a second region is a little more accurate formed. The regional flood quantiles, depending on the regional distribution that we have fitted, worked backwards to the quantiles for the use of ungauged catchment. And how did the computer simulation was done, my friend will explain. How the computer simulation proper has been done will be explained by Sachin Narayan. Sachin Narayan? Hello. Please.
Good afternoon to the dignitaries and the delegates. Once we wanted to find out the subregions in the Krishna Basin, 3H, we adopted this L moment approach, and we got these three regions as explained by senior. So this regional bifurcation or homogeneity or identification of homogeneous regions involves the discordancy, heterogeneity, and identification of the best fit distribution to formulate the zonal equations. The discordancy test is to ascertain whether the group of stations we are taking do follow a reasonable resemblance to form a homogeneous region. Likewise, we found three different regions having the satisfactory DI value well within 3 as prescribed by Hosking. Next area. Next area.
So just use the arrow, down arrow button.
It's okay. Ratios T, T3 and T4 of individual stations, when it is fitted into the program, it will give the DI value finally. And if the DI value is less than 3 for more than 15 stations, those individual stations are considered to be eligible to form a homogeneous region. And whether the homogeneity is correct or not is determined by the H test. H test involves Monte Carlo simulations of artificial regions more than 500 to 1000. We have simulated 500 homogeneous regions based on generation of random numbers, uniform randoms between 0 and 1, and using the regional L moment ratios and fitted in kappa distribution to form 500 homogeneous regions. Based on the parameters of the homogeneous regions and the region under consideration, H test has been performed. H test H test is a statistical measure to assess the homogeneity of the region just we have formed. When H is less than 1, we say it is homogeneous. Likewise, we have found 3 different homogeneous regions in the entire Krishna Basin in Karnataka, and we have found the equations as described by my senior. So these equations will be very helpful in prima facie assessment of a design flood, whether which is well within the earlier assessed design flood for very small dams, which is useful. In case of excess flood, we are getting further rigorous analysis of flood estimation can be made, and dam safety, that is design flood review, can be considered seriously based on these equations. Thank you.
So as a necessary part, we have to conclude. The conclusions are exactly as per our objectives were. We a priori fixed 3 regions, and then we conclude that there are 3 regions by a statistic. So that statistic has proved us the regional parameters will show whether there is a hydrological characteristic through statistic we can identify. It has shown 3 regions. I think our first objective is satisfied. So the regional equations have to be validated. Already 2005 up to 2005 we had the data. Beyond 2005 up to now another 10 years of data is there. We need to revalidate and check these equations before even implementing these equations. The best fit distributions are also candidate distributions are regional scale obtained, and they have good fitness also. The regional studies can be extended to other river basins. What I have observed is the humid region, Malnad area, the west flowing rivers, they are very nearly homogeneous, having a very high regression. The predictions in the Western Ghat area and our Kaveri, Upper Kaveri, are very good regression coefficients, and coming to the arid areas, the regression coefficients are very, very poor. This is what we have found out. Another thing is the river gauge density. To represent over lakh kilometer with 88 gauge stations, I don't think it is reasonable to have any result to be concluded. So we need to increase our gauge density, improve upon our and also we have fixed the without algorithms, we fixed the regions. We need to have clustering methods, k-means clustering or ward clustering methods. We need this technical know-how from the Central Water Commission, and if somebody helps, the Karnataka Research Station is ready to improve this type of research work. Thank you very much.
Thank you, Mr. Shivkumar.
Thank you, sir. Thank you.
I have only one suggestion to make, that such type of studies, the errors associated with the estimates, they are quite large. And in order to reduce those errors, you could also frequency analysis, pooled frequency analysis.
Sir, this has been done. The pooled curves are very nice, braid-like thing. And the 3 regions have given very nice pool. The curves I could not plot here. They have given good pooling.
No, if you are having 88 stations, then it will end up with 88 pools.
Okay.
And for the ungauged catchments, you have to see like to which pool your ungauged catchment will belong to.
Sir, we did use that pooling of the variates for all the 88 stations. In an order, we take the variates, again club the variates, and take a pooled curve. The growth functions are very similar.
No, the pool frequency analysis will end up in 88 pools. And for ungauged catchments, you have to see like your ungauged catchment will belong to which pool. So that will improve your curves, MAF curves, and all these curves, like your correlation coefficients will be far better in that case, and errors will be far less.
But still, sir, the doubt exists in a variable climate. Unless the climate is uniform, we cannot get good regression. Can we expect very good regression because we have very good methodology for analysis?
No, but its pool frequency analysis will reduce those errors.
Yes, okay, sir.
Yeah.
Okay.
Thank you.
Accepted, sir. Thank you. We'll try.
Yeah, so let's thank
Thank you.
now we have 2 industry presentations. So may I now invite representatives of Mrs. Apar Infratech to make their presentation.
Delegates. Good afternoon to all of you. Unlike all the presentation that we just had talking about research and data and surveys, this presentation is more about the materials and some of the solutions that we have just discussed here. Let me briefly start with the introduction of this company, which is headquartered in Vancouver, Canada. They were founded in 1969, and they are as of now present in 108 countries, including India, since 1991. What we do, we actually maintain and strengthen concrete structures and management structures in different segments, starting from marine structures, structures like water and wastewater treatments, bridge structures, power and utilities, that includes thermal power, nuclear power, tunnels, aqueducts, barrages, dams, and irrigation. We play a crucial role in controlling the seepage, the porosity, and the strengthening of these abrasive structures. This material or this technology can be applied in several different ways, starting as a coating, which could be applied on the surface, or an admixture for a new precast concrete, as a patch and repair material for the old construction, or as a grout material where we have a lot of weak or honeycomb areas present there. Just a imagery illustration of how the coating is done. It could be used as a hopper gun or by a brush application. We can use in a precast concrete at the time of construction. For areas where we have water oozing out at a very high velocity, we can use this fast setting plunging material, which